As Ganesh said, I've been, just give you a little background on me. I've been in this business for 37 years. When I came out of college, I started my own factory with my father, who had worked for Kelwood for 30 years. And we started a small little contracting operation in Arizona in the United States. And we grew it to 3 factories, and over the course of about 8 years, 10 years, we sold the business. I went to work as director of engineering for the company that bought it and vice president of operations. And then I joined LeadTech in 1984 and have been with LeadTech almost all of that time, except for a 7-year stint where in January of 2000, I went to work for a company, a Swedish company called Eton Systems. Has anybody heard of Eton? Okay. I was the vice president of sales for all of Eton for 7 years, and we still represent Eton all over the world as well, my company. Right now I work for CGS, Computer Generated Solutions. Computer Generated Solutions is a New York-based company. The LeadTech division I run. I'm the managing director of that division, and we have offices in the United States. We have one in Los Angeles, one in Atlanta, one in New York, and one in Mexico, and now an office here in Delhi. So we'll talk more about that as well. I just wanted to kind of give you a little bit of an overview. So I have a lot of experience in manufacturing systems. I've stubbed my toes lots of times, just like all of us that have been in this business a long time. So let me start off. Okay, now I'm going to start my discussion here. I want to start off by thanking OGTC, its organizing committee, and everyone who worked to make this conference a success. It's truly a pleasure to be here. Thanks again for inviting me. I'm going to start off with a little history, if you will, of apparel and the industry and how we got along. The textile industry, with its extremely long and rich heritage, has been a major impact on world economies through the ages. It is believed that to be one of the oldest surviving crafts in the world, the actual origins of which are thought to date back to Neolithic times, some 12,000 years ago. Even before that time, the same principle was used to interlace branches and twigs to form protective shelters, fences, and baskets. For centuries, both spinning and weaving processes were traditionally carried out by home and a cottage industry basis, weaving by men and spinning by women. The impetus for a major reorganization in the textile production came in the 1700s and the post-industrial revolution, heralding the process of automation in the textile industry as inexpensive, good quality textiles imported from India, China, and the Far East gradually began replacing European goods in international markets. This led to the need to increase domestic production and lower costs by substituting laborious hand processes with more efficient machine operations. The 20th century has witnessed unprecedented changes in the quality of life, aided by rapid technological advancements leading to longer lifespans and taking the global population from 1 billion to over 6 billion by the close of the century. It is further expected that the global population will touch 10 billion in the next 50 years before it starts to stabilize. The continuous improvement in the quality of life and the rising global population in the face of emerging resource constraints has posed a great challenge to the textile industry to innovate new processes, products, and systems to support the growing aspirations of the global consumer. The pace of technological innovation in the garment industry has been slow until the beginning of the 1980s, where in sewing technology, with faster and more reliable, durable machines and the development of attachments for specialized tasks, which later resulted in the emergence of task-dedicated machines. Major technological changes occurred in the 1980s, when microelectronics began penetrating all stages of garment production to some degree. The most significant innovations took place in the pre-assembly stage, where computer-aided design, CAD systems, computer numerical control, CNC cutting systems, and computer-aided computer-aided manufacturing CAM systems led to material and labor savings in those areas. Over the years, a technological gap has occurred between the apparel and textile sectors. While the textile sector has progressed in automation, machine design, process control, and production rates to achieve better product consistency and minimum labor content, the apparel sector has continued to face problems such as intense labor and skill dependency, higher and higher wages, market restructuring, and slow reaction to consumer behavior and market demand. Some of the global challenges. In the last couple of decades, textile companies have accomplished a certain level of process automation by upgrading older machinery and equipment with newer microprocessor-based machines. These islands of automation have had a positive impact on quality, productivity, overall machine efficiency, and costs. However, with the breaking of trade barriers followed by advancements in communication technology and the Internet in the last decade, the rules of the game have changed. In a globalized business environment, it is critical to survival to cut inefficiencies and enhance productivity. The objective, therefore, has to be the following: reduce labor costs, reduce raw material costs, reduce energy costs, improve quality, reduce waste, reduce rework, and reduce capital equipment and engineering costs. A properly implemented strategy of process improvement will provide significant benefits in one or more of these areas, leading to a significant competitive edge in the global marketplace. Friends, despite the fact that the textile and clothing industry is the largest manufacturing industry activity in India, providing direct and indirect employment to about 100 million people, there is no denying that the fact that this centuries-old industry will have to integrate modern technologies not only in production but also in inventory control, supply chain management, distribution, and other areas in order to enhance its competitive strength in today's markets. Today, the Indian apparel industry operates at efficiency levels of 35 to 45% on average. In comparison, countries like Bangladesh, Sri Lanka, Vietnam, China, Mexico, and yes, the United States, work at much higher efficiency levels. The way forward. This calls for bold initiatives on the part of the industry and the government, particularly in areas such as the use of technology, improvements in productivity, employee training, and employee retention. It is in the context of modernization that I believe information technology has a significant role to play in our industry. Information technology can be used by small as well as large companies to succeed because many of the IT tools available today are scale neutral. The Indian textile industry should not underestimate the magnitude of the challenges posed by globalization and global competition. Replacing existing machines with machinery incorporating state-of-the-art control and IT systems to manage the large number of direct labor employees in the country will require significant investment. The question now is, can traditional sectors of the textile industry in India sustain and enhance their market share on a long-term basis? In my opinion, Indian textile and clothing products will always have a niche in world markets. Those forward-thinking companies that embrace change and the technologies readily available will survive and flourish. Those who don't may not. Now let's dig a little deeper into typical problems and solutions for improving your factory operations on the shop floor. Whoop, did I do that? How did it get there? Hold on. I guess my pocket was making the thing go. Apologize. Let's go back here. All right. Okay, so I'm going to walk around a little bit like Ganesh because I can't stand in one spot very long. Okay, the theme of this conference is, of course, make competition irrelevant. And my message to you today is productivity matters. The consequences of poor productivity are late deliveries, which can contribute to lost profits, more canceled orders, more markdowns, fewer replenishment orders. By the same token, quality problems are expensive to correct when they are identified at the source. Early detection translates into fewer problems. Recurring problems are significantly reduced when tailors fix their own mistakes. Increased productivity significantly impacts manufacturing costs as well. More than people realize. Manufacturing costs impact your bottom line. And if left unchecked, the kinds of problems that the U.S. has faced in the last 10 years will be affecting India. This is a graph that shows U.S. apparel manufacturing decline. We used to produce, back in 1997, only import 59% of our consumption. Today we import 97%. It's actually a little bit higher than that now, but it's somewhere in that range. But you can see the trend. Sorry, we're closed. Companies are leaving. Companies are outsourcing. Companies are coming to India. Companies are going to China. Companies are going to Mexico and Latin America. And the reasons are, I think, stable to some, or sound to some extent. But the trouble is, if you're chasing low labor, you're going to be moving your manufacturing around the world and opening and closing plants every 5 to 10 years. So let's talk a little bit about how this decline can happen anywhere, anytime. Low productivity can double, triple, or more your true production costs. We're going to talk a little bit about true production costs. The key to knowing, to making sure this doesn't happen, is knowledge, visibility, and control. I'm going to quote Mr. Kapoor, who on the other night, he mentioned something to me that really resonated because it's absolutely true. He was talking about something called the 3 M's. Man, machine, motivation. You have to have all three. You have to have all three. A lot of people have talked today about incentives. Are they good? Are they bad? Do they work? How do you want to structure them to make them work? There's lots of schools of thought. The point is that incentives do work, and I'll show you some case studies and show you some. We probably have, of all the systems that we have around the world, and I'm going to talk a little bit about that in a minute, I would say probably 90% of them have incentives, maybe 95. There's a few who don't, but those that don't still have what's called measured day work. They pay an hourly rate, but they have a standard for each job, and they measure productivity. So they're still measuring productivity with their operators. They know the high earners. They know how productive their staffs are, and so on and so forth. So if you do all these things, you have a recipe for success. All manufacturers today need systems for management and control and cost control. Plants without its systems for productivity measurement and proper line balancing and line loading are full of surprises. I'm going to talk a little bit about line balancing. Most people don't give it enough consideration. It's probably one of the most important things you can do for your factory. If you're not doing loading, if you're not doing line balancing on your pre-planning, your work going into your lines, you're doomed. You can't have an efficient operation. If you can't finish right if you don't start right. So you have to make sure that you know what the load is. Okay, adding low labor cost is not the answer. And we're going to dive into that pretty deeply here in a second. Adding more tailors and increases your costs and may in fact lower the quality level that you produce for your customer. A lot of times manufacturers ignore everything but the bottom, but the final result rather. They look at what's shipped and invoiced versus what's not shipped and invoiced. You know, I need to get out 400 units a day. I need to get out 1,000 units a day. I need to get out 25,000 units a day. But a unit is not a unit. Depends on the labor content. It depends on what you get for that unit. So your your bottom line can go up and down tremendously. In the final result, when you're in your manufacturing plants, what you are selling is labor. You know, like I think Roger was talking about it today. Or maybe it wasn't Roger. I don't know. Anyway, somebody was talking about the fact that you have, when you're worried about work in process, they're forgetting about all of the work in process. They're only focusing on the little bit of work in process that's on the floor. But you have work in process in the warehouse. You have work in process in uncut fabric and trim and findings, et cetera, et cetera. If you don't control all of that, you're still not lean. Lean is not this. It's this. Okay? So there's a lot of things that you need to do. Don't be satisfied with the status quo. Strive daily to be the best you can be. If you do that, you'll be successful. Management, control, management, knowledge, and visibility is key to having a production facility that's efficient. If you just put work out on the floor, put it in a line, expect things to happen, you're going to be disappointed. So, what are the enemies? I don't know if you can read this. Typical enemies: low sewing efficiencies, poor line balance, poor tailor utilization. A lot of people don't even think about that. Inadequate tailor training, poor work aids, poor quality, high direct labor costs, high indirect labor costs, high excess costs, and high work in process. That's a lot of stuff. That's a lot of stuff. How do you do that? How do you control all these things on a day-to-day basis when you have multiple factories, et cetera, et cetera? If you don't do it, you're putting out fires. I'm going to show you today how to be a proactive manufacturer rather than a reactive one. This is something that is critical. I had my own factories. I ran them, and I know what it's like to be a reactive because we didn't have real-time systems. We had batch systems. We had tickets, gum sheets. Put the tickets out, you know. And what are you doing when you do that? It's not effective. Operators cheat. They get very, very, especially if they're paid incentive. They'll bank coupons. Supervisors will give them coupons from a utility operator to increase their efficiency and all that sort of stuff. There's a million games that operators and production people will play in order to hide the fact that they're inefficient. The only way you can capture true efficiency is to capture things as they happen on the shop floor. I don't suppose any of you guys have these problems, but they're universal. It doesn't matter whether you're manufacturing here, China, Vietnam, Nicaragua. Doesn't matter. They're universal. Every sewing factory has it. Okay, let's talk about how and why productivity matters. True production cost, as we talked about, is not just direct labor alone. It includes indirect labor. It includes non-value-added labor costs. It includes lost time. It includes overtime, which I understand a lot of factories have a lot of overtime here in India. Big problem. And it includes manufacturing inefficiencies. All right, let's look at some numbers. We're going to look at two scenarios here. We have a Latin American company. Direct cost, labor cost per hour is $1.75 on average, and indirect labor or indirect costs are about 400%. So that means your indirect costs are $7 with your $1.75. Your total cost per hour is $8.75. Does everybody understand that? Make sense? Okay. In a low labor country, 76 cents per hour. We're going to, just for the sake of argument, because I want to make things equal, we're going to say the indirect cost is the same. In fact, this can be 1,200%, which really skews these numbers, but we're going to leave it at 400. That means $3.04 in indirect costs my total cost per hour is $3.80. Okay? So obviously, the low labor country has a significant advantage. Or does it? Okay. True production cost. We start off with our 875 and our 380. Productivity in Latin America is 90+%. Low labor countries can be as low as 30% or lower. So what does that mean? When you factor this 875 by 90%, your true production cost per hour is $9.72. The 380 with a 30% efficiency becomes $12.67. Guess what? It's not a low labor country anymore. It's not a cost-effective place for me as a retailer or as a supplier to buy goods from that country. Productivity matters. It's huge. Okay. So, what do the numbers mean? In the global marketplace, plant inefficiencies are a leveling factor. You can't be globally competitive if you don't get your efficiencies up. Does anybody disagree with that? Okay. Productivity of your workforce plays a significant role in remaining cost competitive. What are your plants doing to achieve higher levels of efficiency, productivity? Are you using meaningful incentives? And that's the operative word. Incentives can be, as Roger said, can be help or can hurt. They have to be meaningful. There has to be enough incentive pull, as we call it in engineering, to make the operator want to get there, okay? To want to earn that extra money. It has to be achievable. But on top of that, you have to measure, motivate, and encourage productivity improvement in your operators. Again, if you have tools, you have a machine, you can spend $50,000 on a pocket setting machine. Put an operator on it. If she's not motivated, that machine will not produce at its capacity. So you've wasted some of your investment. By the same token, you can take an operator who's highly motivated and have her set pockets manually and produce more. The 3 M's. The third one is motivation. Operators have to be motivated. Okay. And you also have to remove constraints, which throttle productivity. What are the constraints? The biggest enemy, as far as constraints are concerned, is poor line balance. We're going to talk a little bit more about that in a second, too. Maintain even workflow and proper production loading. When I go into factories, I see operators sitting. Again, somebody mentioned that. Operators sitting. Well, we're changing styles. So, we ran the line dry. Now we're putting work in. It might be a day or a day and a half. Those operators are sitting. That's costing you big money. Worse than that, it's costing you productivity. That is not the way people do it around the world. Okay. You probably all know this, but productivity is affected by many things. Operator skills, motivation and efficiency, line balance issues, excess labor costs, quality problems, equipment issues, training and retraining, attendance problems, and personnel turnover. Those are the things that kill you. How do you get a handle on all these things? You have to in order to be a world-class manufacturer. All right. Let's talk about, we talked about the cost. Let's talk about the savings. Let's talk about what does it actually save me to increase my efficiency. Okay? Latin America, 875, 90% productivity. That means out of the 2156 hours available to them, each operator is effectively working 1,940. Okay? In a low labor country, 318, 30%, 2352 hours rather, 706 hours. We're wasting the difference between these two numbers. That's our inefficiency. That's huge. Now, let's factor that. Let's go a little bit further. Let's say, for example, this 90% turns into 100%. Is there any way you can change that so it's not cutting off the edge here? Can you turn that? Hello? Can you turn? I think you can turn it, can't you? Or they can zoom or something because it's got excess over there. You can see it on this one? All right, we'll go over to this one. I'm easy. Okay, so let's finish our discussion. So if the plant goes from 90 to 100%, he will essentially recoup 216 hours, and he will have 2,156 hours available per year for that particular operator, which translates at $875 an hour to $1,890 per operator per year. Okay. Low labor country, 2352. We're only getting 706. If we can increase the efficiency just to 70%. And I got to tell you, that's not a lot. Around the world, in all of the installations we have, and I'm going to give you we're going to have some case studies here. Companies that are running lead tech never run less than 100%. If they run less than 100%, they're not doing their job. We'll talk more about that. That's a strong statement, but it's absolutely true. They run at 100% or more. If you're running less than 100%, you have a problem. So, but for the sake of the argument here, we're going to say we're only going to go to 17. That gives us 1,646 hours. We're recouping 940. 940 times the 3/8, it's almost $2,900 per operator per year. So for a 400 operator plant, which is a small plant here in India, times the 2,890, that's $1,156,000 US, or 574 lakhs. That's huge. Would anybody disagree with that? And that's just on increasing the productivity. We haven't talked about reducing excess costs. We haven't talked about reducing overtime or eliminating it. You shouldn't have overtime if the line's balanced. Okay. All right. Benefits of a real-time shop floor control system. It makes cost justification easy. You know, people ask me around the world, one of the first questions when people start talking to me is they say, Jim, how much does a system cost? You know what the right answer is? It's free. It's nothing. It's nothing. If this system is saving you as a manufacturer $2,900 a year per operator, and the system only costs you, let's say it costs you $1,000 an operator to put in lead tech, it's going to pay back in a third of a year. 4 months. That's free. Darn close. Okay. There's a couple of ways that and I'm just taking the easy way. There's two ways of calculating return on investment for apparel manufacturer. One is that you calculate if the manufacturer can produce more units with the same people. That's the best case scenario. Why? Because, as somebody said today, you're over-absorbing your burden. And those units become pure profit that go above it. Okay? So your bottom line goes like this. Or, if you have a fixed amount of work, then it translates into fewer operators. You don't need as many machines. You don't need as many supervisors. You don't need as much electricity. You don't need as big a building. On and on and on. Still a huge savings. Because, as I understand, real estate isn't cheap here. Okay. But on top of that, you get, more reliable deliveries, fewer bottlenecks, less work in process, more control. Improved product quality. How can I say that? LeadTech has in it a statistical quality control module. It is an excellent module. It is an excellent system. It was designed in conjunction with Levi. Levi at one point had 32 LeadTech systems. Every single plant they had in the world had a LeadTech system in it, real time. LeadTech, I don't know if any of you remember it, but some of you that have been around as long as me probably remember at one point in time Levi came out with a statement that piece rate was immoral. Does anybody remember that? The chairman of Levi said, piece rates are immoral. We're not going to do piece rate anymore. So he took it out. Plants all went to hourly. Within 6 months, his statement was, we're going back to piecework. Because Levi started losing money like crazy. What's immoral is losing money. Changed his tune completely. Okay. Improved product quality. Again, we talked about, the fact that there's, and we'll talk a little bit more about the SQC system. Fewer surprises. Again, I talked about the fact that LeadTech is a proactive tool rather than a reactive tool. If you're using LeadTech the way it's supposed to be used, but the operative word here is it's a tool. You can't put LeadTech in a factory, plug it in, and not do anything with it and expect results. It doesn't make, as my dad once said, there's an old saying in the apparel business, you can't make a silk purse out of a sow's ear. You can't make a silk purse out of a sow's ear. Have any of you heard that? It's an old statement in the garment industry. But basically, you can't. LeadTech will not make a horrible factory efficient. It'll make a good factory or a medium factory efficient. You have to have strong management. You have to do the right things. You have to react to the information. If you do, great things will happen. Okay. Let's talk, again, back to the theme. Make competition irrelevant. Let's talk about how. We talked about line balancing, very important. Improving productivity. And in our case, we're going to target 70 to 75%. We're going to improve quality and reduce rework, excess cost reduction, and minimize equipment downtime. How are we going to do all this stuff? I'm going to tell you. Hopefully. All right. Let's take an operation list. I told you that I was with Eton for 7 years. Eton is a unit production system. It is a pure lean tool. There is none better. If you want to be pure lean, you buy an Eton system. The problem is it's horribly expensive. It costs $3,000 to $12,000 an operator to put one in. Very expensive. But it also does the job. Okay. So we've got our operation list. This is a rental down, one line. Our present efficiency is 46%. I don't know if you can see this. It's kind of small, but it's 46%. Our target production goal for this line is 550 units in 450 minutes. That's what we want to achieve. Okay. We start off with our operation list. First operation is make yoke. It's done on a single needle machine. This particular line balancing tool allows you to run multiple styles. If you run multiple styles through the line, you can line balance because you can set the percent of total. If you're only running one style, then the percent of total is always 100%. If you're running two, you might have 20% one style and 80% another, etc. The estimated efficiency, I'm leaving it at 46% for this first example. Here's the present standard allowed minutes per unit. No efficiency improvement, obviously. The resulting SAM is the same. We're going to get 550 units out of this job, and it's going to take 4.6 operators, which means I got to have 5 workstations because I can't have half a machine. I need 5 stations for make yoke. 2 for join body and sleeves, etc. Now, you see, they're not all perfect. If you want them perfect, you have to do tack time. Huge. Now you're adding another level of complexity that you don't want to deal with right now. But we're going to look at it just the way it is. So for this particular style, 550 units and 450